Here we've got a problem.
So you have to cut a triangle with a height h into two parts with equal areas by drawing a line parallel to the base of the triangle. Where on h should this line intersect? So, yeah, obviously, like it's not going to be all the way at the bottom or all the way at the top. We need this to have equal areas. We'll probably come up with some sort of relationship, some sort of formula, because we don't know exactly how big these sides are. I think the best place to begin is probably by labeling. So, for example, this line here, the base of this top triangle, we could call base one. And then you'll notice the second shape is not a triangle. It's actually this bottom trapezoid. And that's actually kind of why I used B1 as the top, because we can just make the bottom B2. So, and then this kind of alludes to the formula for trapezoids that we're used to, which is B1 plus B2 over 2 times H. This is the formula for the area of a trapezoid. Now, I'm going to erase H because H in this picture is referring to this entire height, and I think that could get confusing. So I'm just going to get rid of that. And we'll come up with a different letter here for the heights. And we're going to have two heights here. We're going to have a height of the triangle on top, and we're going to have a height of the trapezoid on the bottom. I'm going to think of this height up here for the triangle. I'm going to call this x. I'm going to call the height at the bottom. We know the whole thing is h. The top is x, so that this must be h minus x. Okay. To round out the formula here for the area of the trapezoid, we're going to have h minus x times b1 plus b2 over 2. And then we know this is equal to the area of the triangle. I'm going to go ahead and write the area of the triangle here. And in this specific triangle, the formula would be 1/2 b1 times x. Okay, great. We can set these equal to each other and kind of combine like terms maybe. So let's go ahead and do that. We have h minus x b1 plus b2 over 2 equals 1/2 b1x. So we're going to have to distribute here, which I don't often do with fractions like this, but we can separate this into two fractions and then distribute. We can FOIL. So b1 over 2 plus b2 over 2. And here we're fine. We could write this as b1x over 2, or as we had, 1/2 b1x. And we distribute. We have 1/2 b1h minus 1/2 b1x plus 1/2 b2h minus 1/2 b1x equals 1/2 b1x. Okay, so we have a lot going on here. We can combine like terms here, and I think here at the end I wrote b1. So I meant b2. We're multiplying the second, the last term here. So we'll go ahead and add the b1x to both sides. We have 1/2 b1x here and a 1/2 b1x here. That leaves us with 1/2 b1h minus 1/2 b2h minus 1/2 b2x. And this would now be equal to just b1x. No other like terms. And some people might be thinking, like, maybe I should factor now, like I could factor h out or b2 out. But that kind of takes us back to where we were. And then that happens all the time. Like you'll multiply something out, and then you'll think, oh, I guess I could factor it. We've already done the opposite. You've already multiplied it through. We probably don't want to factor. We want to do something else before we start to factor. I would say here, just to get rid of the fractions, I would multiply everything by 2. So b1h minus b2h minus b2x equals b1x. And that's really all we can do at this point. We have this relationship here between b1h, b2, and x. We want to know if there's any relationship between those from the triangle. And if we look at this triangle, if we look at the larger triangle where h is the height and b2 is the base, the triangle where x is the height and b1 is the base is similar to our larger triangle. So we can come up with a couple of different ratios. We have b1 over x is equal to b2 over h. b1 over x is equal to b2 over h. And so that's the relationship between the sides within each triangle. B2 over, so the base over the height is the same as the base over the height. We could also look at the relationship between these sides. So b2 over b1 would be in the same ratio as x over h. I'll put that here. b2 over b1 would be the same as h over x. Okay, so here we've got a couple of ratios that we might be able to use. Now, these are two fractions, and I see that down here, all we have is pairs of variables being multiplied together. So this makes me think, okay, maybe we should cross multiply here. So we can change, we'll call this equation 1. We can change equation 1 into xb2, xb2, and hb1. We can change equation 2 here, kind of going off the page. b1h is equal to xb2. So I'm not exactly sure which ones we're going to need to use. I know we're going to need to use some of them. But when we look down here at the equation, we have a b1h. That we could replace that with an xb2, and I see an xb2 here. So let's do that. Let's pick a new color here. So we have b1h minus b2h minus, and I can change the b2x to b1h, b1x. Okay, so these will cancel. And now we're left with negative b2 minus b2h. I made an error here. This is an x. Okay, first video. What did I do? Oh, okay. So we added the b1x over here. The b2h, we were adding it here, but I kept this negative. Okay, yeah, this should be positive. So let's correct that. Okay, plus b2h plus b2h plus b2h, and this is a positive b2h. b2h equals b1x. Okay. Oh my gosh. I'm awful. This is a 1. When we multiply by 2, it becomes a 2. So this really is the first time I'm doing this, and this shouldn't get published. We now have something pretty close to one of these over here. I think we should get h by it. So we've got an equation here. I still have a lot of variables. We still have all 4 variables that we created. We want to know about h. So let's get h by itself. So let's say h is equal to 2b1x over b2. And now I can use my second formula here, which says b2 over b1 is equal to h over x. We could also think of this as b1 over b2 is equal to x over h. So b1 over b2 is equal to x over h. So we have h is equal to 2x squared over h. Multiply both sides by h. We have h squared equals 2x squared. Take the square root. And we have h is equal to square root of 2x. So this x we had to define in order to do the problem. And whatever the length of that x is, let's say the height of that smaller triangle was 2, then the entire height would be 2 root 2. Or if the height of the smaller triangle is square root of 2, then the whole height would be 2. I think this was a bit of a challenging problem.